Welcome back everyone. In this session, we are going deeper into one of the most powerful concepts in Grasshopper, data trees. We've already learned how lists work, how data flows between components, and how Grasshopper matches items together. Today, we're going to combine all of those skills and use them in a more advanced and much more fun example. We'll learn how to manage branches, reorganize data structure, and control geometry by shaping the tree itself. And to make this lesson memorable, we are going to create a woven pattern almost like digital knitting using careful data manipulation. This is where Grasshopper becomes truly creative. Let's jump in and start building our data tree logic step by step. Okay, first of all, we need to place a point in Rhino viewport. Okay, I select the point and place it in top view, and we can select a point component, and I would right click on it and select set one point and drag on the point that we place in Rhino viewport. Okay, now for next level, you just need to copy it by move component. I double click on canvas and type move. Okay, and select it. Okay, I connect the point component to a move component, and for motion, double click on canvas and type X and select unit X for movement in X direction. Okay, I connect unit vector in X direction to motion up move component. Okay, we need a series for movement in multiple places, so we can double click on canvas and type series. Okay, I connect the output of series component to factor of unit X component. For start, I double click on canvas and type, for example, 0 and connect it to start. For a step, for example, I type 3 and connect it to a step. And for count, for example, I type 7. Okay. Now we can right click on point and set preview off and drag the point on Rhino and hide it. Okay. Now I want to copy this point in Y direction by movement component. Okay, double click on canvas and again I type move. Okay. In this time we need to connect the result of first movement component to input geometry in second movement component, because I want to move all of these points in Y direction. Okay, connect it. And for motion, in this time, we need to type Y direction, unit Y. Okay, and again, a series. Okay, okay. For example, we type 0 again. 4 in this time, and no, 2 is enough, and for example 9. Okay, now we can see this form on Rhino viewport, but why this form is created in Rhino viewport? Why this movement act like this? Okay, this is a key part of this session. Please pay attention. For movement by this component, we have two inputs. First of them, the points, these points, okay, and second input is movement in y direction. Okay, I want to move these points in these directions, and if you remember data theory session, these 2 points act like this. Oh, sorry. These points move by this direction. These points move by this direction, and every point move by every point moves according to its matching y value. But these two values have not any points to match with them. So in longest list logic, repeat last, the last point of this list move by these two value of y direction. Okay, and we can see the last point of list move by 3 value of y. Okay. But we need a clean structured set of points arranged in rows and columns. So what do we need to do next for having a set of structured points in rows and columns? We have some options. First of them is using cross-reference component, as we do in last sessions. Okay, I double-click on canvas and type cross-reference and movement to list B and geometry to list A, and it. Now we have a structured set of points arranged in rows and columns. Okay, but we can try another way to make this network of points. If we have this list with one item, how these two lists work with themselves? Point number 0 moved by y number 0, and the other y directions by longest list repeat last logic connect to first point on to the last. Okay. By this logic, if we can change this list by 7 items 0 to 6 to 7 lists with 1 item in each list, we can experience this setup of matching lists. Okay, for change this list to with 7 item to 7 lists with 1 item. First, I delete cross reference, connected. We can right click on output and please pay attention. Select graph, change the list to lists. Okay, and now we can see each item in each list matches with all of y direction to move. Okay, and the result is a network of points that we want. Okay, Now we have this network of points. Let's a little deeper into the result list of movement of these points. We have 7 lists from 0 to 6 with 9 items for each list. The list say to us that we have 0, 1, 2, 3, 4, 5, 6. We have columns as a list and rows as items. Okay. These lists. List num. This is lists of points, and this is item of each list. Okay. We can see in another way the result list by select on param viewer. Okay, select on it. We can find it here and connect geometry to it. Okay, data with 7 branches, and each branch has 9 items from 0 to 8. Now we have a data tree. We have a tree with 7, 1, 2, 3, 4, 5, 6, 7 branches, and each branch has a 9 item. And we can see the data tree here with param viewer. Okay. Now you can see the same number in each list, 0. Twice we can remove it from list number by click right on the output and select simplify. If a number repeat in each list name, it's removed by right click and select simplify. Okay. So we want to select branches in odd and even numbers. Let's type the name of leads on Rhino viewport to knowing better the logics. Okay, click on Rhino viewport, type text and 0 scale to the list number 0, list number 1, 2, 3, 4, 5, 6, 2, 3, 3, 4, 5, and 6. Okay. If we want select an item in some lists, if you remember, we can use a list item. But if we want select a branch, some branch in a data tree, we need to use tree branch component. First, I connect the geometry into tree and type a number 0 double point 2 6. By double point, we have a special range of numbers in number slider. Okay, 0 to 6. Select on tree branch to see in a green color in Rhino viewport. List number 0, list number 1, list number 2 to list number 6. Okay. But we want to select branches in odd and even numbers. So we must create a series. Double click on canvas, type series, and create a even numbers series. Even numbers start at 0 and step is 2 and count 1, 2, 3, 4. We have 4 even numbers in this list, but this list may increase or decrease, so we need to connect the count input of series component to a logic, to algorithm, and not a special number. So we have 7 columns, and the count input of component series before x direction is numbers of lists. Okay, so we need to divide this number. We need to divide this number by 2. Okay, let's do it. Double click on canvas, type division, connect 7 to A input, and type 2 for B input. Okay, and drag and drop it to here and connect the result to count. And the result of series, we can see 0, 2, 4, and 6. It's correct. Okay, connect it to path, and we select the even numbers of branch of this data tree. Okay, now we must select the odd numbers of branches. I drag all of it and Control C, Control V. For odd numbers, the series start at 1, and the count of series also this number divide 2, but when we divide 7 by 2, we have 4 number. Actually, we have 3.5, and Grasshopper round it to up, and we have 4 count, and we don't have the 7 list. The list that its name is 7. It's okay. Just the component is red, and this color is saying us a number in input. The number, the input doesn't have matching item in 3 branches. Okay, it's okay. We have branch number 1, number 3, number 5, and branch number 0, 2, 4, and 6. Okay, let's go next step. In the next step, we want to select the items in each list in odd numbers and even numbers again. But in this time, we need to select items, not branches. Okay. As we say in last sessions, we just need to double click on canvas and type call pattern. Call pattern. This list first I connect even lists to call pattern, and double click on canvas to type pattern 0, enter 1, and pay attention, don't enter after 1 like this. If you enter after 1, we have an empty line, and it's incorrect. Okay, back select backspace, and I select on canvas. Now we have a panel that is that its content is a text, but we have a list of numbers 0 and 1. For achieve this list, we should right click on the panel and select multi-line data. Okay, I connect it to call pattern. Now we select the even numbers of even branches. And I want select the odd items of even branches. Okay, drag call pattern and its pattern, Control C, Control V, double click on pattern, and in this time we would be able to type 1 and 0 for pattern and press OK. Okay. Now we have the even and odd items of even branches. Okay. I want to repeat these steps to odd branches. Drag these two components and its pattern, and Control C, Control V, and connect odd branches into it. And now we have even number of odd branches and odd item of odd branches. Okay. Now we have all we need. Okay. Now I double click on top viewport in Rhino and double click on perspective viewport to see perspective of this network of points. I want to move some points, some selected points in Z direction. Okay, I select the odd items of even branches and type move and connect these items to geometry of movement. And for motion, I would be able to select unit Z, and for example I type 2.5 for the number of movement. Okay, and I would be able to I would right click on the call pattern and set preview off, but we can see them yet their preview on in this component, and so I right click on it and set preview off, and in this component we can see it, so I right click on it and set preview off. Okay, now 0.8 is good. Okay, and we want to repeat the last session in this session, last session exercise in this session. We have some points on the ground and some points on the air, and I want to weave them together and draw a polyline between them. Okay, I double click on the canvas and type weave. Stream 0 is the stream in on the ground, and the stream 1 is this list. Okay, pattern. I create a panel with 0, 1 pattern. Don't forget, pay attention. Right click on it and multiline, and select multiline data pattern. And now we can connect interpolate line to these points, and now we have this curve. Okay, now we repeat these steps to odd branches. Okay, but this time we need to move the points upward whose neighboring points is stay on. So I select the even items of odd lists. Okay, double click on canvas, type move with same Z direction. Okay, and right click on it, set preview off, set preview off. Okay, and set preview off. Okay, now we have these two lists, and we need to type weave the points that moved in z direction is 0 stream, and the other list is 1 stream, and the pattern is 0 1. Right click, multi-line data, and pattern. Okay, and interpolate line. What if we face to a bug that caused to the color of component is being red? It's enough to connect the panel to the input, and that list that the list that doesn't exist make this trouble, but it's okay. We need this curve, and we have it. Okay, now and we want to do all of these acts on flip lists. Okay, when we see the output, the data tree output of the result of a second movement in y direction, we see 7 lists with 9 items. That it means the columns is list, but we want to change this arrangement. We want the lists, the branches with rows, and the items with columns. Okay, if we want to see it on right now, move it and set it's off. Okay, we need to this arrangement. 9 branches with 7 items in each list, in each branch. Okay, 0 1 2 3 4 5 6 7 and 8. 9 branches with 7 items in each list. But how we can change this arrangement, the old arrangement, to this arrangement? For change arrangement, we need to a component that it is called flip matrix. Flip matrix. Okay, this component. When we connect a data tree to flip matrix, the old data tree, and now we can see the new data tree. Now we can see we have a new data tree with flip branches. The old data tree, in the old data tree, we have 7 branches with 9 items in each list, and now we have 9 branches with 7 items in each. Okay. Now we can do all of these acts into this new arrangement of data tree. Now we set this preview of this off, but set preview these 2 curves on, and set the flip items and branches on. And now we want to select the odd branches and even branches. We must double click on canvas and type tree branch, and we need to create series for even numbers. Start at 0, the 2 number 4 steps, and in this time, because we need rows as branches, we need to connect the count of series input of movement of in the y direction to count of a series of tree branch. but before it we need to divide it by 2. Okay, we connect the number of rows, because in this time by flip matrix our branches is the rows, not columns, and the numbers of rows created in y direction. If you remember, we have some points in here, and by movement in y direction, by this count, we have the rows of points. So we need to connect the number of counts that connect to movement in y directions to divide, and type 2 and connect it, and connect the result into count. Now we have 0, 2, 4, 6, and 8. It's correct. And now we have the even branches of this new arrangement of points. And for odd branches, we need to drag all of it and Ctrl+C, Ctrl+V, and it's enough to type 1 instead of 0. And now we have even branches of these new lists. Okay, and the same trouble, and it's okay. Okay, and now we must do select the odd and even items. Call pattern. I want to do this faster. Pattern. I want to select even items, so I need to type 1 and 0, right click, multi-line data, even items on of even lists or even branches, and the another branches, odd branches, 0 and 1. Okay, and these 2, 4 odd branches. Okay, now when we want to move some points to in the z direction, we need to set preview of these curves on. Now some points that are on the ground in non-flipped data tree, we must move it in z direction. For example, these points that are on the ground in another arrangement, we should move it in z direction. Now move, and the same z direction. Okay, and these points on the ground and this point under air, weave first these points, second these points, and the pattern is first string 0, then string 1, and right click, multi-line data. Okay, and interpolate line. Okay, we can see it when the other side is down, this side is up. Okay, and the same acts for another branches. Okay, if these points are on the ground in another arrangement, we should move them in z direction. Okay, the same z, and Ctrl+C, Ctrl+V, first these points, second these points, and we have, now we can drag all of the components and press scroll on mouse and set preview off. But these 4 branches of curves, and now we drag on it and move this curve, and now we can see a woven form, and now we can connect all of them to pipe component with this icon. Create a pipe from each curve. Radius is 1.2, for example. We can change it. Okay, 0.4 is good. And for cap, I right click on cap and select round. You can see the type of cap of pipe, or flat or round. I select round, and by holding shift on your keyboard, you can connect more than one geometry to input of pipe component. And now we can erase it. Okay, now we can drag on interpolate line, press scroll on mouse and set preview off, and now we just see the result grep, the result pipes. Okay, and now we can right click on the output of pipe and select bake. By select bake, we can have the result in Rhino. I select the default layer in Rhino, and for group I select yes please and okay. Now we have the result in Rhino. In rendered view, we can see the result woven form. Okay, now we can change these items, and we can see our forms is extended. The big benefit of algorithmic design is that everything follows rules, so you can change anything anytime without breaking the system. Okay, that's it. Thank you for watching this session. I promise that in the next sessions we will have even more exciting exercises.